Hi, this is Massimo. Just wanted to give a quick update on the NeoAGF development. Camera towards my desk, which is a mess, but excuse me for that. So I'm gonna start with the electronics. Thanks to JLCPCB, we were able to receive these beautiful ESP32C3 based boards. We got 5 of them in 10 days. And also thanks to Sri Ram, our designer, our electrical engineer. So I have 2 mounted on a breadboard, 3 left for the actual devices. So the boards have the main CPU. They have 2 DACs and 1 ADCs to both read and stimulate the EEG sensors. So I'm gonna first show the stimulation part. I have this board is connected to my Mac. I'm running Arduino IDE. The code is creating a sine waveform. Right now it's just relatively high voltage for EEG, but this is just for testing. But it works beautifully. I'm monitoring the output with an oscilloscope, and a beautiful waveform is generated. Eventually, this waveform is going to be in the millivolt range. And these output is going to drive these EEG sensors, electrodes rather than sensor. This is my first attempt at forming carbon nanotubes electrode. I think it didn't cure quite well. We have a few more coming up, but this is conductive and is rubber and carbon nanotubes. This is gonna sit and on the forehead here. There is a let's see if I can get. There you go. Well, anyway, it's gonna sit in the slot, and it's gonna be driven by the electronics here. So I'm gonna stop for a second, and I'm gonna set up the reading scenario. Thank you. Hey, this is Massimo again. So I got my EEGs attached to 2 positions. This is not necessarily superficial, probably could be positioned better. There's also a ground attached to the back of my head. But this is just mostly for testing the electronics. So this is the other board, and I have the EEG sensor wire going into the ADC, which is the BioAmp EXG design. So I have, we're also going to show Bluetooth connectivity. So I have our BLE server advertising here. And I'm gonna start the client. She is looking for a device. And there it is. We found the device, and they started communicating and sending raw voltage values. At the moment, we're going to be doing the analysis on the client side. Eventually, a lot of it is going to be done. I have written just a very simple visualizer here and a very simple analysis, Fourier transformation to bucketize the frequencies into delta, theta, alpha, beta, gamma. So this is definitely shouldn't read anything into that because the signal still needs to be cleaned. Bandpass filters and other things that digital signal processing algorithms that need to be applied is quite a science. Yeah, we're showing full end-to-end from the electrical pulses in my brain all the way to the PC through Bluetooth. When Bluetooth is on, we have when there is Bluetooth connectivity, we have an LED. And yeah, as you can see here, as I move around, there is some variance, which is yeah, a lot to experiment with, a lot to fine tune, but we feel that we're in a pretty good spot given the short period. Yeah, that's it. Again, shout out to Port Labs. It's an amazing co-working space for hacking, all sorts of software and physical devices. And shout out to the rest of the team: Rohit, Patrick, Chayet, and Shriram. We've all been working really hard to get this done. All right, thank you.